Hi, right, we were talking yesterday about AC coupled inverters. One of the things which I didn't cover, and somebody came on to me about it, is charge discharge. So when the sun is shining, automatically charging the batteries up, and when the sun goes in, so we're actually going to use the batteries as a reservoir. So in this setup, we've set it up 2 inverters. This inverter is being used as just a normal grid-tied inverter. We've used one of our hybrids without battery, and this inverter we've done it as a hybrid inverter connected to a battery pack. So there are 2 different things going on. Here we've got our load, here we've got a meter. So this meter is monitoring the power in and out of the grid. So what we've got on here now, if we show on this inverter first of all, we will show that we've got a small 190 watts generation. So we're only using our solar emulator, and we can see here 192 watts, and this is being exported out of the grid, into the grid. So it's connected here, and on this block, this is like your consuming unit. So I've got my existing grid tied inverter, which may be a micro inverter. Here I put on my hybrid inverter. Here is my load. This could be just a normal consuming unit. So imagine it's a normal consuming unit. So here, as I say, I'm monitoring the wattage. So as I increase my wattage here, you'll see what's going on here. The mains, it takes a slight adjustment, but I'm running about 20 watts. So now I increase it here, and you see my mains pull is still 20 watts. The energy is coming from the battery. Now here's the interesting thing, is if I take off all the load, this thing is still producing, and you'll see what happens here. It takes a short time for it to react, because obviously the inverter has to reverse. You'll suddenly see the power will drop very quickly, and suddenly you'll see it dropping down, and it'll drop down eventually to 20 watts. It'll settle at 20 watts. You see it's 20 watts. So what's going on here? So if I click on here, and you'll see I am now charging the battery. So you'll see very clearly the battery is being charged with the energy. So this is the energy coming from this inverter. Because I'm not using it, it is charging the battery. If I now keep watching this, if I suddenly take some power out of here, and you'll see what's going to happen here, I'm suddenly taking the energy, the battery's reversed. It's now discharged. It's true AC coupled. The settings are very simple. So I explained on a previous video about the setting. The only thing you need to be aware, if you go onto auxiliary load, microinverter, these are my 2 settings. This is when on the AC coupling, when it will charge the battery and when it will switch off from the battery. We have these 2 settings here. It's quite important. 0 export. So we set it like this. The other setting is to be aware of is on the system mode. I'm using the controller, and on mode 2, I've got 0 export, priority to load. This is my trickle charge. I've set it to 20 watts. So this is the power that's actually pulling from the grid at any one time. The reason for that is because of the prepaid meters. So you go onto your auxiliary load, you set your microinverter, you set your upper and your lower limits like that, and you also set your battery to make sure your battery setting is correct. All the other settings, obviously you've got to make sure you've got communication with your batteries. Very, very important. So as long as your inverter is communicating with the battery, and that's good, this system will work, and I'm proving it here. It works a treat, and it's absolutely spot on. I've tried to. So if you're using an AC coupled, and you know, I mentioned in a video yesterday about my little bird telling me about in Australia that they're going to be charging you to export power. Well, of course, AC coupled devices are going to be massive in Australia. Exactly, inverter, battery. UK is going to be the same thing. It's to do with the grid stabilization, because too many people are trying to export energy. So this is the future, absolutely the future. So if you're not too sure, let us know. But I'll try and do an install document. It's really, really simple. There's nothing to it. It's a very simple program. Most important thing, you don't need lots of CT coils. One CT coil is on the main grid feed in a single CT coil, and that goes to the hybrid inverter. And the hybrid inverter could be a master and a couple of slaves. The only time you would need multiple CT coils if you're using 3-phase, where you'll need 3 CT coils. Single phase, of course, 1 CT coil. Even if you've got 10 inverters in parallel, 1 CT coil. You don't need to use the CT coil from the microinverter or the grid-tied inverter. You don't need to do any of that. All it will do is the excess power, it will be picked up from here, and it will feed it back into the battery, and it will cycle the battery. It works magic. Thank you for watching.
Choose smart energy. No